Push that rock here with Simpson Math. Let's integrate some trig integrands like this one. You really hope for this odd power here. That's very helpful. But before I integrate this, I want to talk about a game that we used to play back when I was in athletics in middle school. The coach would have us pick two captains. We'd have a couple of captains. It was always the better athletes. And then each captain would pick players. And this game was called Odd Man Out. And I'm not sure it was that they'd be allowed to play this anymore. So Captain 1 picks this player. Then Captain 2 picks this player. And Captain 1 picks this player. And Captain 2 picks this player. And Captain 1 picks this player. And Captain 2 picks this player. And so now everybody's got 3 each, and then there's an odd man, and he would be out. He wouldn't get to play, but he would do something. He would have some other role to play. Coach would make him referee or whatever. So that's probably a little bit cruel because, of course, the kids would always pick the best athlete, then the second best athlete, and then the guy left out on the end, he's, thinking to himself, well, I guess nobody likes me. So, but whenever we did it, I was probably some very often odd man out, and I never felt that way, I don't think. So I don't think it was that bad. But I bring up that story because maybe it happened to you and it'll help you integrate something like this. When you're integrating something like this, you're going to do the odd man out. You're going to rewrite sine squared x cos to the fourth x, and then you're going to put that odd man, that third power. See, there's 2 here, so here's the third one. You're going to put it out, okay? And now that this one's out, we want everything to be cosine. And so I'm going to change that to 1 minus cos squared x, because sine squared we know is 1 minus cos squared by the Pythagorean identity, okay? And then I can even distribute this, leaving this out here. So I'll have, let's see, cos to the fourth x minus cos to the sixth x sine x dx. And now maybe you can see what's coming. I'm going to let u be cos. Well, then that means that du is, let's see, the derivative of cos is negative sine x dx. Now, I don't have a negative sine x dx, so I'll multiply both sides by negative and get negative du is equal to sine x dx. So that means that I can put u in for this cos and this cos, and I can put in negative du for sine x dx, because a negative du is a sine x dx. So when I make my substitution, I have u to the fourth minus u to the sixth, and then I have a negative du, but I'm going to kick the negative out here because it's a scalar multiple. It's a negative 1, so it's a scalar multiple, so I can kick it from here out here. Okay, so I substituted in for sine x dx, and I substituted in for all the cos, so now I'm just going to integrate by power rule. So when I integrate, by power rule, you add 1 to the power, and you put the reciprocal out front. And then here you add 1 to the power, and you put the reciprocal out front. Okay? Then I can distribute the negative. So this will be positive. I'll put it first. And then that will be negative. And then what was u? U was cos. So we have 1/7 cos to the 7x minus 1/5 cos to the 5th x. And don't forget your plus c, baby. And that's how you use odd man out. Math made simple at Simpson Math.